Now let's work on the second part of the substitution technique. So there's called Bernoulli's equation. When we have this type of format of the differential equation, we call it Bernoulli's. So the left-hand side, we have seen this, right? That is linear equation. And when we have integrating factor, we have integral e to the integral p of x dx. That's the format. But we cannot directly use that because on the right-hand side, we have a y to the power of something. So it's not linear. So for the Bernoulli's equation, we're going to make this guy to disappear. In order to do that, we're going to use this substitution u equals to y, 1 minus n is from the right-hand side, the power of y. That way we can cancel that. So let's work on this. It's not standard form, so we want to make it to standard form. Then dy over dx plus 1 over xy equals xy squared. That's standard. When you say standard, the coefficient of dy over dx has to be 1. It's not linear. Therefore, we're going to let u equals to y 1 minus n. This is n. So we're going to let u equals 1 minus 2. Okay. Now, once you know properly do this step, then it's just like in a linear equation. Okay. So when we let u equals to y to the negative 1, now I'm going to change this to y equals u to the negative 1. So always y equals to something. You let y equals to something. And then we need to take the partial derivative of here. That's the tricky part. dy over dx equals negative 1 times u, negative 1 minus 1 du over dx. Therefore, dy over dx equals negative u negative 2 du over dx. It is done. So once you do this properly, you're done like 80% of the work, the Bernoulli. Now what we want to do, just substitute this and this to the original equation so that we don't want to see any y in the equation. So dy over dx, we said that is negative u negative 2 to the power du over dx plus 1 over x, y equals u negative 1 equals x, y equals u negative 1 square. Now we want to make this to standard form again. Now this differential equation is now du over dx. It was dy over dx, but it's not linear. But if you make this standard form right here, du over dx, then it's going to be linear. If you multiply everywhere by negative u squared, you're going to have negative u negative 2 negative u squared du over dx plus over x times u negative 1 negative u squared equals x u negative 2 negative u squared. Now, we multiply these together. So negative negative is a positive. U negative 2, u2 is going to 1. From here, u negative 1 and u squared. So we'll have a u. From here, we have a u negative 2, u squared. So this is 1, this is 1, this is u. Therefore, we have du over dx plus 1 over x negative u equals to x negative du over dx minus 1 over x u equals to negative x. Now we need to work on the integrating factor. So our integrating factor, integral negative 1 over x dx equals negative dx the negative ln x, x power. Now cancel out. Then we multiply x negative 1 everywhere. Du over dx negative 1 minus 1 u negative 1 negative x negative 1. X negative 1 is 1 over x. So this portion again, so d over d u negative 1 equals, this is negative over x. Now we take the integral for both sides. Then we have u x negative 1 equals negative xc. Now we said u equal negative 1. So we put it back to y negative c. So 1 over y, 1 over x, negative x plus. And this is a solution. If I say explicit solution, well, we need to flip both sides. xy equals 1 over negative x plus c. And you need to divide x for everywhere. Y equals 1 over negative x squared plus explicit solution, a solution, implicit. So problem 2.5.16, that's on the YouTube. Okay. So I want you to work on this and check your answer with my answer. So I'm not going to work on that here. Instead, we're going to work on 2.5.19. Make to the standard form. So dy over dt plus 1 over t squared y squared equals d over t squared y. We have to switch these two guys, right? Because the second one, we have to have y to the power of 1. Right? That's the standard form. dy over dt minus 1 over t y equals negative 1 over t squared. So this is standard. Okay, u equals y 1 minus n. So here u equals 1 minus 2, negative 1 equals negative 1. Then chain rule dy over dt this time equals negative 1 minus 2 du t. Y equals to u to the negative 1, dy over dt equals negative u to the power of negative 2 dt. Plug that in. So we have negative u over dt minus y equals negative 1 squared, y squared, negative squared everywhere. Then du over dt minus 1 over, it's going to be plus 1 over t u plus 1 over, so now it is a linear. So we're going to work on integrating factor. That is the integral 1 over t dt t. So multiplying t everywhere, du plus the left hand side. Now we're ready to take the integral equation that we discussed. U times t equals let by negative 1. Put it back over y. So I'm going to flip this y over c multiply t. So this is our of the problem.